Hydrocarbons. We know organic compounds are made up of hydrocarbons. There are two types of hydrocarbons, saturated and unsaturated carbons. If you see the structural things, we divide the hydrocarbons into two categories, open chain, closed chain. Open chain are called alicyclic compounds, and not all, few, and most of the closed chain compounds are aromatic. Some of the closed chain are also alicyclic. In alicyclic compounds, we go for alkanes. Alkanes, let us see their preparation and properties of alkanes with the help of this slideshow. So let us see this slideshow. Go to the beginning. Alkanes. If you see the structure, alkanes have carbon-carbon single bonds. That means alkanes are saturated hydrocarbons. And as alkanes are saturated hydrocarbons, they have carbon-carbon single bonds in it. Each carbon will be in sp3 hybridization, and hence here you see two types of alkanes, straight chain, that means open chain, and this is closed chain hydrocarbons. They are called cycloalkanes, cyclobutane, cyclopropane, cyclohexane, and all these things. So their general formula is CnH2n plus 2, CnH2n plus 2. For one carbon, there will be 2n plus 2, 2n plus 2. That means for one carbon, there will be 4 hydrogen. For two carbon, there will be 6 hydrogens. All ethane, methane, propane, butane, hexane, octane. They are called paraffins also because of their. They are also known as paraffins due to their so alkanes are there are two types, that is open chain and closed chain. Open closed chain are called cycloalkanes. They are alkanes. So alkanes means whenever we consider alkane, alkane should be open chain alkanes, and they are called paraffins because of their less reactivity, or they show less affinity towards chemical reactions. General formula of alkane is CnH2n plus 2. They have carbon-carbon single bonds, and they undergo substitution reactions because of their saturated nature. Let us see some methods of, let us see this classification. Alkanes are saturated hydrocarbons containing only carbon-carbon single bond in their molecule. They are also called paraffins. Paraffins means they are less reactive because due to their saturatedness, they are less reactive. At high temperature and pressure, they do undergo some chemical reactions. As we have discussed, alkanes are divided into two categories, open chain and closed chain. Open chain are called acyclic, and cycloalkanes, that means closed chain, they are called cyclic alkanes. Let us see the preparation of alkanes. Alkanes are prepared mainly from natural gas and petroleum products. There are few other methods by which alkanes are also prepared. Mainly they include unsaturated hydrocarbons, from alkyl halides, and from carboxylic acids. There is one or two more reactions that we will discuss in our class. This is simple method you have seen in lower classes also, that is unsaturated hydrocarbons. Unsaturated hydrocarbons are alkenes and alkynes. You might have studied in lower classes. Alkenes containing carbon-carbon double bond and alkynes containing carbon-carbon triple bonds. When these unsaturated hydrocarbons are hydrogenated, that means we add hydrogen in it. Alkenes are there. If you add one hydrogen molecule, they become alkanes. Alkynes are there, you add two hydrogen molecule. This is called hydrogenation. Hydrogenation is taken place in the presence of catalyst, ranny nickel, platinum, palladium, heavy metals. These are heavy metals. They are used in the hydrogenation of alkanes. So here we see the reaction. This C2, CH2 double bond CH2, that is ethylene, and hydrogen is added. We get, in the presence of this platinum, palladium, and nickel, we get alkane. The simple method is this, nothing more in it. From alkyl halides, except fluorides, remaining alkyl halides, chlorides, bromides, and iodides, on reaction with hydrogen or reduction, is also called reduction of alkyl halides, and reduction of alkyl halides gives alkanes. So alkyl halides except fluorides on reduction with zinc and dilute hydrochloric acid give alkane. This simple reaction. Chloromethane, when it is reduced, we get methane. Chloroethane, when reduced, get ethane. So you may further go for some other reactions. Another reaction, very important reaction for the preparation of alkyl halide, that is Wood's reaction. This Charles Adolph Woods, he gave this reaction. This is a very unique reaction used in many of the reactions. Alkyl halides, two molecules of alkyl halide, when they are reacting in presence of sodium metal, they give higher alkanes. This reaction is known as Wood's reaction, and it is used for the preparation of higher alkanes. Methane cannot be prepared because two alkyl halides combine here. So methane cannot be prepared by this method. See, simple method, simple reaction. Methyl bromide reacting with sodium in presence, another molecule of methyl bromide. Two molecules of methyl bromide, two molecules of sodium. When they are kept in dry ether, they react to form ethane. You can prepare so many reactions with this. This is very important reaction. Here bromine, and this bromine is being removed. This bromine is bromine, and sodium. Sodium bromide is given out. You have another reaction from carboxylic acid. There are two methods of preparation of alkanes via carboxylic acids. One is decarboxylation. That means when we heat any acid strongly, what happens? The carbon dioxide is removed and we get alkanes. This is one method. This method is used for the reduction of preparation of carbon or removal of carbon dioxide. Aqueous solution of sodium or potassium salt of carboxylic acid on electrolysis gives alkane containing even number of carbon. You see here, sodium acetate in presence of water, that is electrolysis, we are getting alkanes. This is called Kolb's electrolysis. So what happens in Kolb's electrolysis? This is Kolb's electrolysis. Sodium or potassium salt of carboxylic acids. When the aqueous solution is electrolyzed, we are getting alkanes. This is one method. Next, let us see the mechanism. Mechanism contains anyhow two steps. Initiation, reaction starts. Any mechanism contains three steps. Initiation, that means reaction starts. Propagation means reaction continues, and reaction ends. Initiation, what happens here? First is this sodium acetate. Here sodium ions are given out and you get a acetate ion. That means the salt is undergoing ionization. Next, in the second step, that is called propagation at anode. We know that the negative ions go towards collected at anode. Two electrons are given out and we get a methyl free radical and carbon dioxide gas. These methyl free radicals combine to form ethane. So two sodium acetate molecule giving ethane. Termination, how reaction stops. The water present in the solution forms H plus and OH minus ion. They again combine to give water. That is the reaction. So we have seen 4 or 5 methods of preparation, and this is very important reaction. Corey's house synthesis of alkane. Corey house synthesis of alkane. You are asked in examination separately how alkanes are prepared from Corey house reaction. In this reaction, the alkyl halides are reacted with lithium. That means lithium substitution takes place. In alkyl halide is first converted to lithium dialkyl copper here. The metals are replaced here. Metal substitution is taking place. The alkyl halide reacts with this lithium, forming lithium substituted ethane. And when lithium substituted ethane again reacts with copper iodide, we get another substitution of copper here. Here what is there? Lithium dialkyl copper. Lithium dialkyl copper. Again, the two molecules combine with alkyl halide. Another molecule of alkyl halide combines. All the metals will combine with the chloride ion, and you get, what are you getting? When you have started with ethyl chloride and you are getting butane here. So here also doubling is taking place in Corey's house reaction. So remember, in Corey's house reaction, the alkyl halide or ethyl chloride is first treated with lithium, and the lithium substituted ethyl molecule is again reacted with copper iodide to get dialkyl copper lithium compound. Lithium dialkyl copper, because we start with the lower metal, lithium dialkyl copper. It is again reacting with another molecule of ethyl chloride, and these metals combine with this, and we get butane. This is very important reaction. That is Corey's house. Let us sum up. Alkanes are prepared by different methods. If we want to sum up this lesson, alkanes are saturated hydrocarbons. They contain carbon-carbon single bond, and they undergo less reactions, and they show less reactivity towards chemical reactions, as they are called paraffins. But they undergo many reactions at high temperature and high pressure under different conditions, and they give different types of compounds. And so let us see, there are two types of alkanes we can study. Open chain, they are called alkanes. Closed chain, they are called cycloalkanes. Next, they are prepared by, I'm summing out, they are prepared from unsaturated hydrocarbons, alkyl halides, and carboxyls. These are the main reagents through which they are being prepared. Unsaturated hydrocarbons. Here, unsaturated hydrocarbons means alkene, alkyne. With alkene, alkyne, when they undergo hydrogenation, you are getting, when they are undergoing hydrogenation, you are getting this compound, that is alkanes. Alkynes also, when they react with two molecules, they are hydrogenated, you are getting alkanes. So they are prepared from alkyl halide by many methods. By Wood's reaction, Grignard reagent. Grignard reagent means when alkyl halides react with magnesium, and on hydrolysis they give alkane. Simple reaction. And from alkyl halide also, Wood's reaction. That means two molecules of alkyl halides reacting with sodium, giving higher alkanes. From carboxyl, from alkyl halide only, Corey house reaction, that ethyl chloride first reacting with lithium, forming lithium substituted compound. When it undergoes with copper iodide, it forms lithium dialkyl copper. Lithium dialkyl copper again react with another molecule of ethyl chloride and gives butane. See, in Wood's reaction and Corey house reaction, the number of alkyl groups are increasing. So higher alkanes are prepared by Wood's reaction and Corey house reaction. Whereas through Grignard reagent, we are getting same number of carbon atoms as they were in alkyl halides. From carboxylic acids, there are two methods. By decarboxylation, that means when carboxylic acids are heated, carbon dioxide is removed. Suppose acetic acid is there, CH3COOH, When you are heating, carbon dioxide is released and you are getting one alkane. If you go with higher acids, you get higher alkanes. And there is another method from carboxylic acid, that is Kolb's electrolysis. Two molecules are here also doubling reaction taking place. Two molecules of ethyl acetate. The aqueous solution, when it is electrolyzed, we are getting ethane. One ethyl acetate contains sodium acetate contains one molecule of methane, that is CH3 methyl. So two molecules are formed. So here you have to keep in mind what are the different methods. How can we obtain alkanes from alkyl halides through different methods? Means from alkyl halides, Grignard reagent, Woods reaction, Corey-House reaction. 3. From carboxylic acids, we have 2. Decarboxylation and then Kolb's electrolysis. So a very important reaction, keep in mind. In Kolb's electrolysis, you should be able to write the mechanism. I'll just go through the mechanism once again. The mechanism contains two steps, two-step mechanism. So one is chain initiation, how chain is initiated. Here, sodium acetate deionizes. In chain initiation step, sodium acetate gets ionization, that means acetate ion and sodium ion is formed. And in the propagation step, two molecules of acetate ion in the propagation step. What happens? At anode, acetate ion moves towards anode, loses its electron, forms methane. And termination means water molecule undergoes hydrolysis, ionization, and again these reactions are formed. So the very important one is Corey's-House reaction. Just try to write the reaction. Alkyl halide is first converted to lithium dialkyl copper. How? Ethyl chloride reacting with lithium and copper, forming lithium dialkyl copper, which undergoes this eliminations and form this butane. So this is how alkanes are prepared. In today's class, I think we have seen the preparation of methods of preparation of alkanes. And if we go for properties, in the beginning only I told you, alkanes are less reactive. They show less affinity for chemical reactions. Hence, they are called paraffins. So paraffins, but under some high temperature and high pressure, they react. So this is how this reaction, this is the class. You just concentrate on preparation of alkanes. Remember, preparation is very important. So concentrate on 3: Woods reaction, Corey-House reaction, and Kolb's electrolysis. So this is for your class today. And in the next class, we will be seeing the properties of alkanes. So till then,